Okay, so get this, right. Today, we are diving into the world of biohacking.
Sounds intense.
It is. It really is. It's not just some, futuristic buzzword anymore, though, We're seeing biohacking everywhere.
Yeah, it's true.
But it's a lot to wrap your head around.
It is a lot. Where do you even start with it?
I know, because we're talking everything from, fancy coffee
Right.
to, wait for it,
Okay.
implanting magnets into your body.
Oh, yeah, I've heard about that.
Magnets in your body, though, seriously.
Yeah, some people are into that. It's wild. It really runs the gamut, biohacking. You've got everything from simple tweaks to the downright extreme.
Okay, so on one end, we've got things like tracking sleep or experimenting with different diets. Who hasn't tried to find the perfect morning coffee routine, right?
Sure.
But then it goes from coffee to full-on sci-fi territory.
Exactly. You're talking about things like DIY, gene editing, things that used to be confined to these, high-tech labs.
Hold on, back up. DIY gene editing. How is that even possible?
CRISPR. It's a gene editing tool, and people are using it at home.
Okay, first off, CRISPR. What even is that?
So CRISPR is like a super precise pair of molecular scissors. It lets you target a specific sequence of DNA and literally cut and paste genes.
Wait, people can edit their genes at home now?
Yeah, some are trying to. It's still early days and very complex, but the kits are out there.
Wow. So you're saying anyone could potentially get their hands on that technology? That is both amazing and a little bit terrifying.
It's that double-edged sword of biohacking, incredible potential, but huge potential consequences. It makes you stop and think.
It really does. It's like we're on the verge of this incredible new frontier.
Yeah.
But we have zero maps and a lot of unknowns. Speaking of unknowns, let's talk about these biohackers. Are we talking about rogue scientists or your average DIY enthusiasts? Who are these people?
It really is a mix of everyone. You've got scientists like Josiah Zayner, for example. He went from working at NASA to experimenting with gene editing, but on himself.
Wait, he was doing gene editing on himself?
Yeah. He's like a key figure in this DIY biology movement.
Wow.
But it's not just scientists. You have hobbyists in community labs, even people experimenting in their basement.
Basements.
Yeah, basement.
That makes it feel incredibly real. It's not some far-off future anymore, right?
Yeah.
It's happening right now, in basements.
It really highlights how accessible this technology is becoming. Like I said, you can buy CRISPR kits online for a few $100 now.
Really? CRISPR, the gene editing tool?
Yeah, the gene editing tool.
You're telling me anyone can get their hands on that?
It seems that way, yeah.
Wow. That's both amazing and a little terrifying.
That's biohacking for you.
It really is. Okay, so let's talk about CRISPR for a second. For those of us who aren't geneticists, how does it even work?
So imagine CRISPR like a pair of incredibly precise molecular scissors. It allows you to target specific sequences of DNA and literally cut and paste genes.
Cut and paste genes. So we're not just talking about tweaking our sleep schedules here. We're talking about messing with the very essence of who we are.
It's true. And it's not just you, right? These changes, they could even impact future generations. That's a heavy thought.
That's a heavy thought. It really is a heavy thought. But these ethical dilemmas, they aren't just hypotheticals, right? There are real people making these choices right now.
Absolutely. Real people with both inspiring and, cautionary results.
Okay, so let's talk about some of those real-world examples then. What are some of the success stories that make biohacking seem almost within reach?
Well, you mentioned that special coffee earlier, right? Bulletproof coffee.
Yeah.
That's a prime example of biohacking, or at least biohacking concepts kind of creeping into the mainstream.
Yeah, that's everywhere now. And the guy who created it, Dave Asprey, he's practically a biohacking guru now.
He really is. I mean, he claims he's aiming to live to 180.
180, isn't it a little, I don't know, ambitious?
Maybe not. But the point is, he's built a whole empire around this idea of biohacking for wellness supplements, special diets, light therapy, all of it. Whether or not he actually makes it to 180, he's definitely onto something. People want to feel better and they want to live longer. And biohacking might just hold the keys.
It's fascinating and a little bit intimidating, right? Like hacking your way to a longer, healthier life. It's almost relatable. But then you have stories that make you wonder if we're getting ahead of ourselves. You mentioned Aaron Trawick earlier.
Right. Aaron Trawick, he was a big proponent of this DIY gene therapy, very vocal about making these technologies accessible to everyone. He actually injected himself with an experimental herpes treatment on stage.
On stage, in front of an audience?
Yep.
Wow.
Yeah.
That is something else. Okay, what do you think would drive someone to do something so public, so risky.
It definitely got people talking. Some people saw it as a publicity stunt, but others saw him as, I don't know, a kind of a visionary. He was trying to make a statement about the potential of biohacking, about the need for wider access to experimental treatments. Sadly, he passed away just a few months later.
A few months later.
Yeah.
That's a stark reminder that this isn't a game.
It really isn't.
So where do we go from here? It feels like we're at this crossroads. Do you see biohacking becoming more mainstream or more regulated?
That's a good question. The million-dollar question, really. Because on the one hand, you have these tools and technologies becoming more accessible every day, right?
Right.
And you've got this growing community eager to experiment, pushing the limits of what's possible. So in that sense, it feels very much like the Wild West out there. But on the other hand, governments and regulatory bodies, they're starting to pay attention, especially after some of these extreme cases.
Yeah, I can see why.
So I think we're going to see a lot more regulations trying to strike that balance of, personal freedom versus public safety.
It does feel like the Wild West, like you said. That can't last forever, can it?
I don't think so. Not with the potential risks we're talking about.
Right. But at the same time, it's not like you can just, stuff the genie back in the bottle.
Yeah.
People are excited about this stuff.
And for good reason. There are some genuinely exciting possibilities here.
Exactly. So where do we even go from here, it feels like? I don't know. Are we going to see biohacking become more a part of regular life, more mainstream?
I think so. In some ways, it's already happening. Look at how many people are tracking their sleep or their steps or their diets. That's all kind of biohacking, isn't it?
Yeah, I guess, in a way. Okay, so more mainstream, but
Okay.
How? How does that happen?
Well, that's the million-dollar question, right? But here's something else to think about. This line between biohacking, the kind of stuff we've been talking about, and regular medicine.
Yeah.
That line's going to get blurry. What we think of as radical today could be standard practice tomorrow.
Like what? Give me an example.
CRISPR. Still relatively new, right? But it has the potential to completely change how we treat genetic diseases. And that's coming from within the world of, established medicine.
So it's almost like biohacking is kind of pushing traditional medicine forward.
Yeah, it's pushing the boundaries, forcing the medical community to catch up a bit.
Okay, I see what you're saying. It's like this weird symbiotic relationship or something.
Right. It's pushing us to rethink what's possible, but it's not without its issues, of course.
Like ethical questions, right?
Exactly. And those are conversations we need to be having now. As individuals, as a society, what are our limits when it comes to, ourselves? What risks are we willing to take? How do we make sure these technologies are being used responsibly and ethically?
That's a big one.
Yeah.
There's a lot to think about and a lot of responsibility, too, for everyone involved.
It really is. There's no easy answer.
No easy answers. Well, you've given us a lot to think about today. This has been an incredible deep dive into the world of biohacking. And this is really just the beginning of the conversation, isn't it?
Oh, absolutely. I think we're just scratching the surface here.
So next time you come across some article on biohacking, whether it's about, a new diet or some crazy gene editing experiment, just take a second. Ask yourself, is this the future we want? And at what cost? That's all the time we have for today. Until next time, thanks for diving in with us.
Okay, so get this. Today's deep dive is going to be about something pretty wild. CRISPR.
It's a big one.
It really is. Ever kind of just wish you could, reach into your DNA and fix a typo?
Yeah.
That's basically what CRISPR is, the molecular version of that, right?
Yeah, it's really remarkable. We're talking about a tool that lets us make really precise edits to DNA, and that just opens up a whole universe of possibilities. I mean, treating diseases that we thought were incurable, creating crops that can handle, climate change. It's a lot.
It really is. Honestly, all this reading I've been doing for this has just been sci-fi coming to life.
Yeah.
So before we get ahead of ourselves, can you break down exactly what CRISPR is? How does it work?
Absolutely. Okay, so imagine you've got these molecular scissors, right?
Yep.
That's basically CRISPR. And these scissors can be programmed to target a specific DNA sequence in a cell. And the way this programming works is through a molecule, RNA, which acts as a guide, basically taking these scissors to the exact spot on the DNA that needs to be edited.
Okay, so the RNA guides the CRISPR to the right spot. Then what? It just snips the DNA.
Yeah, pretty much. The scissors are actually a protein, Cas9, and when it finds that target DNA sequence, it just cuts it.
Huh.
Now, here's the really cool part. Once that DNA is cut, the cell's own repair mechanisms, they kick in to like try and fix the break.
So it's freaking out like, oh no, my DNA is broken, gotta fix this.
Exactly. And so scientists can use this natural repair process by giving the cell a DNA template that's been modified a little bit. They can trick the cell into swapping that cut section with a brand new edited sequence.
So we're basically like hijacking the cell's own machinery to rewrite its genetic code. That is wild. No wonder people are calling this revolutionary.
Oh, it's a game changer, for sure. Think about it. We're not just masking symptoms anymore. We're talking about maybe addressing the root cause of genetic diseases, like at the DNA level.
Right.
And it's not just medicine either.
Right. I mean, this could revolutionize so many fields, like agriculture, right?
Huge.
Can you tell us more about that?
Yeah, of course. So imagine crops that are naturally resistant to pests, to diseases. We could reduce, maybe even eliminate our use of all these harmful pesticides.
Yeah.
Crops that can survive drought conditions, which would be huge for farmers dealing with, climate change and unpredictable weather.
It's like we could engineer crops that are custom built for the challenges of, the 21st century.
Exactly. And it's already happening. We're seeing disease-resistant pigs being developed, cows that make more milk, but with less resources, even mushrooms that stay fresh longer.
Wow.
It's a really amazing time to be looking at the future of food.
Yeah, it sounds like CRISPR could be essential in tackling global food security, which is huge.
Absolutely.
But what about the medical applications? Where are we seeing the biggest breakthroughs there?
So one of the most promising areas is definitely in treating genetic diseases. For example, there's this woman, Victoria Gray.
Okay.
She was one of the first people to get CRISPR treatment for sickle cell disease. And her story, it's just incredible.
I've heard about her. She was living with chronic pain before the treatment, right?
Oh, yeah. For years, Victoria was dealing with these really bad pain crises. I mean, they put her in the hospital multiple times a year.
Wow.
But after getting CRISPR therapy, her life totally changed.
Really? So the treatment worked? They actually edited her DNA, and now she doesn't have that constant pain?
Well, it's still early days, but so far the results have been amazing. Victoria doesn't have those debilitating pain crises anymore, and she's living a much fuller, healthier life.
That's incredible.
And, what's even more amazing is that her case is paving the way for other people with sickle cell disease to get this life-changing treatment too.
That's amazing. Just incredible to think about how a technology like this could offer that kind of hope to people with these debilitating genetic diseases. Yeah.
It really shows the potential of CRISPR to, maybe even rewrite the future of medicine.
Yeah, it really does. And the thing is, we're just getting started, really. Researchers are looking into using CRISPR to treat everything.
Wow.
Cancer, cystic fibrosis, even Huntington's disease. The possibilities are kind of endless.
So we've talked about the incredible potential, but let's switch gears a bit.
Sure.
What about the risks involved? Because you mentioned it's not exactly a magic bullet.
Right.
What are some things we should be cautious about?
Right. Well, as with any really powerful tool, there are always downsides. There are always potential risks to consider. And one of the biggest concerns with CRISPR is something called off-target effects.
Off-target effects. Okay. Sounds kind of ominous. What does that even mean?
Okay. So imagine you're trying to edit a document, right? And you accidentally replace the wrong word.
Yeah.
You replaced a word that's similar to the one you meant to change, but it's not quite right.
Yeah. That's basically what off-target effects are with CRISPR. The Cas9 enzyme, those molecular scissors, they might accidentally cut the DNA at a spot that's close to the target, but not exactly it.
Oh, okay. So it's like a near miss, but with potentially huge consequences?
Exactly.
So what happens? What happens if the DNA gets cut in the wrong place?
Well, it really depends, on where that cut happens, but it can mess up how a gene works, interrupt its function, or even introduce a harmful mutation.
Oh, wow.
So that's why scientists are working so hard on improving CRISPR, making it more precise to lower the risk of these off-target effects.
So we're still in the beta testing phase, essentially, trying to fine-tune this tool, which is incredible, but still needs some tweaking to make sure it's as safe and accurate as possible.
Yeah, exactly. And as we get better at controlling CRISPR, the potential just keeps growing.
Yeah.
But with that potential, there are also more and more ethical considerations that come into play.
And that's a whole other layer to this. It's like we're entering uncharted territory, ethically speaking. Where do we draw the line with this kind of ability to edit the very blueprint of life?
That's the big question, isn't it? And there are no simple answers. One of the biggest ethical debates right now is around something called germline editing.
Okay, germline editing. Remind me what that is again.
Sure. So germline editing means editing the DNA of embryos or sperm or eggs.
Right.
Those are the cells that pass down genetic information, to future generations.
Right. Okay.
So if you make a change at that level, it's going to be hereditary.
Okay, so we're not talking about just treating an individual's disease.
Exactly.
We're talking about potentially changing the DNA of their children, their grandchildren, and so on, like way down the line.
Yeah, exactly. And that brings up all these questions about consent.
Oh, right, yeah.
About what are the unintended consequences that could have a ripple effect down through generations. About whether we even have the right, as humans, to make these kinds of changes that could be passed down and become permanent.
It's a lot to grapple with. It really is. It's almost like this technology is making us confront some really big, really basic questions about what it means to be human.
Yeah.
And what limits, if any, we should put on our ability to, to tinker with the building blocks of life itself.
It's true. And it's not just some philosophical debate either. There are real world issues we have to think about, things like access and equity. Imagine a future where you have these amazing CRISPR treatments, but only wealthy people can afford them.
Yeah, right. You'd have this whole new level of inequality, a genetic divide, basically, between the haves and the have-nots.
Yeah, and that's a real concern. And then on top of that, you have this whole biohacking community to consider too.
Right, exactly. If this technology keeps becoming more and more accessible, what's to stop people from, experimenting with CRISPR in their garage?
Exactly. And it's a very valid concern. And we're already starting to see examples of it happening. You had that biohacker, Josiah Zayner, who made headlines a while back.
Right.
He actually injected himself with CRISPR, trying to enhance his muscles.
I remember reading about that. Seemed incredibly risky at the time. So what does that tell us, that kind of DIY CRISPR experimentation? What are the implications of that?
Well, I think it really highlights how important it is to educate the public. We need people to be aware of how complex CRISPR is, how many potential dangers there are, because it might seem simple on the surface.
Right, I can just edit this and it'll be fine.
Right, but it's incredibly nuanced, and it requires a deep, deep understanding of genetics, of molecular biology, to use it safely, to use it effectively. We can't just have people messing around with it without knowing what they're doing.
It's like, rewiring your house with zero knowledge of electrical engineering. You might get lucky, or you might get electrocuted.
Exactly. And when you're talking about editing the very essence of life itself, well, the stakes are a whole lot higher.
That's a great point. So how do we find that balance then? Because on the one hand, you have this incredible potential of CRISPR to cure diseases, to improve our lives in so many ways. But then on the other hand, you have these very real risks, these ethical concerns. What's the path forward, do you think? So where do we go from here? With all this, the potential, the risks, the ethical stuff? What does the future hold for CRISPR? Any predictions?
Well, predicting the future is, always a gamble. But I think it's safe to say CRISPR is here to stay.
Right.
If anything, I think it's going to become even more, integrated into our lives in the next few years. One area I can see really taking off is personalized medicine. Imagine, instead of just general treatments, we could use CRISPR to develop things tailored to your specific DNA.
Oh, wow. So you're talking about custom designed therapies based on your own genetic code?
Exactly. We're already seeing the very beginning of this with gene therapies for some rare diseases. But CRISPR could make personalized medicine so much more precise and, available to a lot more people. Imagine being able to just edit out a gene that makes you prone to certain cancers or heart disease. Essentially, you're rewiring your DNA for a healthier future.
That's kind of mind-blowing. But with that level of personalization, would everyone even have access to that kind of treatment? Or are we talking about, healthcare that's only for the super rich?
That's the big question, right?
Yeah.
And it's a challenge for sure. One of the biggest ones we face, I think, is making sure everyone has access to these technologies, not just a select few. Mm-hmm. The benefits of CRISPR, they shouldn't be limited to just the wealthy.
Absolutely. What about the ethical questions? It feels like with CRISPR, every time there's a new breakthrough, there's also this whole other Pandora's box of dilemmas that comes with it.
Yeah, and that's a good point. I think CRISPR is really forcing us to rethink some things, our values, what it means to be human. For example, let's say we can edit out genetic conditions before a baby is even born.
Right.
Does that mean we should? What about, using CRISPR not just for diseases, but for enhancements, like making people smarter, stronger, faster? These are big, complicated questions. There are no easy answers.
It's almost like we're, playing with fire. CRISPR gives us this immense power to basically shape the future of life.
It's true.
But as always, with great power comes great responsibility.
100%.
Yeah.
And, I think the real takeaway here is that this isn't just a conversation for scientists to have or even just ethicists. This is something everyone needs to be talking about, thinking about, because we all have a stake in this. We all have a role in figuring out what the future of CRISPR looks like by, talking about it, weighing the potential benefits against the risks, and just making our voices heard.
Absolutely. Well, this has been quite a journey, exploring the world of CRISPR with you today. We've covered so much ground. It's amazing to think about it all, from how it actually works to the incredible things it could do to these really complex ethical questions that come with it.
Yeah, and it really shows you how fast this field is moving, how much of an impact it's going to have on our lives, on everyone's lives, really.
Yeah, absolutely. And for everyone listening, if you're as fascinated by CRISPR as we are, we encourage you to, go out there, read up on it, stay informed, and join the conversation. This is the future, and with CRISPR, we have a say in shaping what that future looks like. And on that note, that's it for today's deep dive. As always, keep exploring, keep asking questions, keep diving deep into all the wonders science has to offer.